To code with Momo. Today we're going to be solving valid palindrome, and I'm going to create a playlist so that you see all two pointer solutions. So the approach I'm taking in solving problems now is to identify patterns. So let's look at valid palindrome. So a phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all of alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. So it says, given a string S, return true if it is a palindrome or false otherwise. So we see this string here, and it is true. So let's look at it together, shall we? What they did is that they joined everything together and they tested it. So if I flip this backwards, it's still going to tell me the same thing. The same thing with race a car. So race a car cannot be a palindrome. Why? Because this E and A cannot be flipped backwards. So it's not possible, right? Even in example 3, we see that an empty string should be true. Okay, so because even when we flip this empty string, it's still going to be the same thing. So this is how I'm going to solve it. I want a situation where I'm calculating it without the spacing, right? There's no spacing involved. And so this is what I did. I used a two-pointer approach where, first of all, I understand that we want to include, we want to remove all non-alphanumeric characters, right? And we want everything to be lowercase. So the first thing I did was to reassign S to be a lowercase value. But I might end up placing this in a different variable instead, so that I do not change the data set given to me originally. So what I did first, let's call this filtered S. I joined each character that has a space inside. I joined it together. Another thing I did was I ensured that I changed my characters to be lowercase. After changing my characters to be lowercase, I checked each individual character to see if it is an alphanumeric, it is not a numeric value, right? To make sure that it's actually a text. So let me try running this again. Let me see. I'm probably missing. Okay, yes. So this is meant to be s.filtered, s underscore filtered. Okay, let's run it again. So yes. So now I assigned my s. After I cleaned the data, I stored it into filtered s. Now I'm using the two-pointer approach, where I first of all, in this solution, right, I put the first pointer at 0, which is called left. Then I put the next pointer at the end of the test case given to me. Then what I do is I check while left is less than right, meaning when it does not meet. What am I doing? I'm saying that if these values are not the same, it can never be a palindrome. Then if that's the case, I return false. So what I'm doing next is I am moving my left pointer forward. Then I am moving my right pointer backward. In any situation where it's not the same, I am going to return false, which is the situation here where A and E are not the same. Else, I'm going to return true. Now, let's look at the time complexity of this algorithm. The time complexity is going to be, I believe, from here to here, the time complexity is going to be O of n, because n is the number of characters in the string. However, the algorithm will only run n over 2 times, since the pointers are traversing towards each other. And the space complexity here is going to be O of 1. So, YouTube family, the thing is, the space complexity will be an O of n because I am reassigning this value. So the time complexity is O of n, and the space complexity is O of n too. Thank you so much for watching. Have a beautiful rest of your day. I pray God keeps you. Bye bye.